bid for the Mockingbird Olefins Corporation, and we're part of the Distillation class at University of Tennessee Chattanooga. We'll go over a little outline with you today. We're going to do an introduction of what the problem is that we're going to address. We'll give you some information and assumptions that we had to make to go through the calculations that we did to come up with our final product. These include, we had specified values and criteria given to us, our research values, assumptions, and determined values that we calculated. We'll talk about the method that we decided to go with, the cost and economics of that method, and give you some conclusions and references. So in introduction, there are 2,000 gallons of a 66% methanol solution that needs to be distilled through continuous distillation. We're looking to obtain a 99% methanol solution in the end. We have to use the UTC distillation column, and this gives us specifications that there are 12 trays that have to be accounted for, and that the feed stage on this column is stage 7, so this cannot be changed, and this has to be factored into our calculations. There's a partial reboiler and a total condenser. Information and assumptions. We had the specifications given to us by Mockingbird Olefins Corporation, and we had the UTC column specifications, and we also had the specification to use a methanol water binary system, and we also had to make several assumptions. So our specified values are feed composition was 66 mole percent, and we were looking for distillate composition of 99 mole percent. We knew that we had to have at feed stage 7, we had to have 12 trays, and we were given 2,000 gallons of a 66% methanol solution. The values that we had to research were the heated vaporization of methanol, which was 16,079.11 BTUs per pound mole. The heated vaporization of water was determined to be 17,476 BTUs per pound mole. We had to research the cost of water and energy. To the best of our knowledge, it cost about 76.9 cents per 100 cubic feet of water. And this was from the American Water Corporation, which supplies water to the Chattanooga area. And from the EPB's October numbers, we determined that it cost approximately 0.00272 cents per BTU. We had to make several assumptions. We assumed that the column operated at 70% overall efficiency. The efficiency will normally vary from tray to tray, but to get the best approximation, we approximated that it was 70% overall. We assumed that we had the accurate energy and water rates. We assumed that the column is going to operate for 24 hours a day until the distillation is complete. And we also decided that we think the best way for this to happen is to use student workers and pay minimum wage, $7.25 per hour. It will be fairly simple to operate, monitor a computer, and we felt this would be appropriate. We had several determined values. We used feed setting of 2 on the distillation column. It fed in at 0.0955 liters per minute. By using the program Distill that several people have discussed today, we determined that our reflux ratio was 14.7. We determined this was the minimum reflux ratio we could get by getting 99% as our distillate composition. And we determined our bottoms product composition was 1% methanol, or 0.001 on here. And we determined that it did not need to be heated or cooled, so your F value, your fraction that vaporizes, is going to be 0.
This is just a process flow diagram of the column that is located downstairs. As you can see, it has the 12 trays, the reboiler, and the condenser with reflux. This is the column that is downstairs. For our reboiler, this is just how we are actually going to operate the column. The reboiler needs to be filled to the low water sensor with the 66% methanol solution. And then once that is heated to boiling and heats up to tray 7, starts at tray 12 and will heat up to tray 7. And once that is heated, we will turn on the feed setting to 2, so that the 66% methanol will begin actually feeding into the column. And the feed containers, we have the actual feed container, and then we have a distillate container. The feed containers will be on the ground floor, so we need to extend the feed tube up to the column. And And then for the distillate container, we are going to use the empty feed containers. So we also need to extend the distillate pump tube to fill back into the distillate containers. Just to tell you the column conditions again, we have a reflux ratio of 14.7, feed setting of 2, and the cooling water flow rate 5 gallons per minute. And as she said before, we want this column to operate for 24 hours a day. And to do this distillation is going to take 52 days and 20.16 hours, so about 53 days. Close enough to count, 53 days. Just to tell you some of the cost and economics, one of the reasons that we did choose a feed setting of 2 is because the bottom product could overflow if we had a much faster feed rate. And if it overflows, then our bottom product will not be properly distilled. So, and the final amount that we will end up getting is a little over 1,560 gallons of the 99% pure methanol, and then we'll end up with a little over 440 gallons of the water containing the 0.1% methanol. And then this is just a small chart of our costs. The total energy cost of the condenser is $2,420. The reboiler energy cost was about $2,625. The amount of the water volume that is going to be run through the condenser was $344. And then the cost of labor for the student pay was $9,194. That brought our total cost to $14,584. And then when we add the 10%, just to be on the safe side, we never know what's going to happen, or if it takes a slightly longer, or the cost of the extended tubes to get to the feed containers, we end up with $16,000 and $42. So the conclusions, just a quick rundown again of everything, our final product. We're going to run the reflux ratio at 14.7 with a bottoms product of 0.0011% methanol. And then, we have a feed setting of 2. It's going to take 52 days and 20 hours for the distillation. We're going to end up with 1,560 gallons of 99% methanol, and the total distillation is going to cost $16,042. So this is just showing you the product from the Distill program that was used. It was prepared by Dr. Cunningham and Mr. McGann, and it shows our feed stages and how many stages we are actually going to have. And then this is the XY versus T diagram for methanol water system. It was this was also used to put into the Distill program. We used the ENCH equations and the Van Laar constants that we got from Harry's Handbook data and analyzed. And it's just the references we use for everything. Does anyone have any questions?
Could you show me your McCabe-Teal diagram again? Can you describe that to me? I see X equal Y line, and then I see a line real close to it. What is that?
So
You see the X equal Y line?
this is
It's red, isn't it?
rectifying section, your stripping section.
Those are the what?
Your rectifying section here and your stripping section. And there's your feed.
Oh, and so this is real high reflux ratio, so
Yes.
it's real close. Okay.
To get the percentage, that was the minimum reflux ratio that we could.
Say that again?
To get the 99% product, and this was the lowest reflux ratio that we could come up with using Distill, that would actually work.
No, give us the proper amount of trays and the feed stage 7.
If the efficiency was higher, it could have been a little bit lower for your reflux ratio. But with that low of an efficiency, it would not work properly.